Hello students, today we start a new topic in a chapter number 12, linear programming of a construction management subject. So topic is a solution of LP problem. LP means linear programming problem by simplex method. So let us solve the previous problem for door and window. The model development is in a last lecture we discussed about the model developed by the simplex method is maximize z is equal to 500 x1 plus 600 x2. So here in a 500 is for a door and 600 for a window, and subject to the 3x1 plus 4x2 less than or equal to 64, and x1 plus 4x2 less than or equal to 68. So here x1 and x2 greater than or equal to 0. So it's a simplex the model developed by the using the linear programming. Now we shall write the general form of objective and function, and constraint is z is equal to 500 x1 plus 600 x2 plus 0 s1 plus 0 s2. So z minus 500 x2 minus 600 x 500 x1 minus 600 x2 minus 0 s1 minus 0 s2 is equal to 0. So subjected to here 3x1 plus 4x2 plus s1 is equal to 64. Example like 3x1 plus 4x2 plus 1s1 plus 0 s2 is equal to 64. Similarly, another equation we find out the x1 plus 4x2 plus s2 is equal to 68. So like x1 plus 4x2 plus 0 s1 plus 1 s2 is equal to 68. So here x1 always greater than equal to 0, x2 greater than or equal to 0, s1 always greater than or equal to 0, and s2 is also greater than or equal to 0. Now in initial simplex table is here basic, coefficient, solution and ratio is given. So in a basic there are the three basic is there, z, so it's variable, and s1 and s2. So initial table show the s1 and s2 as a basic variable, and x1 is a minus 500, another is a for s1 is a 3 and 1. Similarly in a column number 3 is x2 is a coefficient is a minus 600, 1 and 4, and in a column number 4 s1 is a 0, 1, 0, and in a column number 5 s2 is equal to 0, 0 and 1. So here solution is that z is equal to 0 for s1 is equal to 64, which is already given in a example, and s2 is equal to 68. Now ratio is 0 divided by 600. So x2 and solution we got the ratio. So 0 is equal to 0 divided by 600, 64 divided by 4 is 16, and 68 divided by 4 is 17. So initial table show the s1 and s2 is a basic variable, and z is equal to 0, and decision variable x1 and x2 are non-basic at this stage and are equal to 0, and s1 is equal to 64, s2 is equal to 68. Now simplex iteration will be increase the value of the non-basic variable on at the time and check whether the optimal solution is reached or not. So here, since this is the maximized problem selection of entering the variable is a basic maximum is a negative coefficient, and negative coefficient in a z row is a minus 600, and next is a non-variable which now known as entering variable is a x2. So selection of leaving the basic variable is based on the least positive ratio. In this example s1 is a leaving variable with least ratio is a 64 divided by 6, which is already we calculated here, and is equal to 16, and similarly for x2 as explained earlier, and z row is a minus 600, we get the ratio is a 0 divided by minus 600. Now similarly the ratio in S1, so this 64 divided by 4, and S2 row 68 divided by 4. Answer we got this 16 and 17. So here maximum positive ratio is a 16 in a S1, and S1 is living variable, and the row contain the living variable is known as a pivotal row, and the dotted row and column are pivotal row and column, and after entering the living elements are obtained, new basic feasible solution is obtained by Gauss-Jordan row operation. So here the other elements are computed by equation is a basic, coefficient, solution and ratio. So here basic is a z, x1 x2 and s2 is given. So x1, x2, s1 and s2 is a coefficient is given. So minus 5 and minus 50, x2 is a 3 by 4, s2 is a minus 2, x2 is a 0, 1, 0, and 150, 1 by 4, minus 1, and for s2 0, 0 and 1. So now solution we got the 900, 9600, 16 and 4. Now ratio is a solution divided by S1, so minus 9600 divided by 50. Similarly 16 divided by 3 by 4, and 4 divided by minus 2. So it's we find out the ratio for a solution and x1. So now element of the row matrix is equal to old elements minus elements in a column of the old elements but in a pivotal now, and multiply by elements in row of old elements but in a pivotal column divided by pivotal elements. So here another table is a simplex matrix after iteration 2. So here in table basic, coefficient and solution is given. Now in a basic is a z, x1 and s2. In place of the here x2 we put here x1, and x1, x2, s1 and s2 is a coefficient, and solution is we find out. So z, x1 and s2 is a basic. For x1 coefficient is a 0, 1 and 0. For x2 coefficient 200 divided by 3, 4 by 3 and 8 by 3, and s1 is 50 by 3, 1 by 3 and minus 1 by 3, and similarly 200 divided by 3, 0 and 1. So solution we find out is 10,666 is a final solution, and next for x1 is 64 divided by 3, and s2 is 46.66 is another solution. Now the matrix in a z row, all the elements either positive or 0 or negative, thereof the optimal solution is reached. Now in a final iteration matrix, the row contain x1 elements is 64 divided by 3 in a solution column, and x1 is equal to 64 divided by 3, and in a z row column is 10,666. So in a graphically we have obtained same answer is 10,666. Now here we stop our lecture, and here chapter is finished, linear programming in construction management. Thank you.